Welcome, guys, to the lecture on machine learning. Here, we will try to dig a little deep into this concept. So, let's start by getting a common idea about what is machine learning. Machine learning is a field of computer science that often uses statistical techniques to give computers the ability to learn with data without being explicitly programmed. Now, so machine learning is a field of computer science, yes, okay, that uses some magical mathematical techniques or statistical techniques like correlation, finding the strength of linear relationship in our data, etc. Okay, by using these statistical techniques, we can give our computers the ability to learn by themselves on the basis of data. So data is very much important. Okay, so what is learning? Now let's focus on that. So what is learning? We will go on to this definition from Wikipedia. A computer program is said to learn from experience E with respect to some class of task T and performance measure P. Okay, now here three things are introduced. First thing is the experience. Experience means the number of iterations or the number of attempts a machine has made on that specific task. Okay, and the second thing is the task itself. So task example like playing chess. Our machine is trying to learn how to play chess. And the third thing is the performance measure. Okay, performance measure uh, that basically measures our performance, that how well are we doing on the specific task. Now, if its performance at task T as measured by P improves with experience E, we say the model is learning. So, when is the model learning? It learns when, with increasing experience, our performance also increases. Okay, now that same applies to us also. Okay, like if you are trying to play chess, if we are trying to play chess, and with our experience, we are improving in playing chess. So we can say that we are learning. The same goes for our machines. Now let's move on to types of machine learning. It is broadly classified into three major categories. The first category is supervised machine learning. So let's see. In supervised machine learning, we train our model, the learning algorithm, like example, a linear regression model is a learning algorithm. Linear regression model learns on our data set. What it learns, let's see that. Okay. Now, for example, first classification, a classification problem, and the task here is to classify that image we are supplying is either of a cat or a dog. Okay. Now, and one thing to note is the supervised models are task driven. They are designed to perform better at a specific task. They are designed to learn a specific task. Like example, here the task is to classify a dog or a cat. Okay. Now, while training, we provide labels also with each image. Like the first image is of a dog, so we provided a label with it that it is a dog to tell the algorithm while training that this is a dog. So learn to recognize it. Okay, learn to detect some features so you will be able to recognize it later. Like examples, some features of cat are whiskers, pointy ears, and these things. Our algorithm learns these features, so afterwards it can recognize the image. Okay, now same goes for regression, but regression is predicting continuous values. Okay, continuous variables, like example, stock price. But in classification, what we do is to predict discrete variables, discrete values, like example, either it is a dog or a cat, either it is 0 or 1. But at stock price, we have continuous range of values. Okay, so now that was supervised machine learning. Now the next one is unsupervised machine learning, which is data driven. Okay, here we don't specify a task to our model, for our model to be better at. We just give our data, and the model has to mm, figure out itself the patterns. Okay, like example, the first example is of clustering. Clustering example, here is our data. As you can see, all the data points are of same color. Okay, just the data points are plotted here, and after applying an our algorithm on this data, like example k-means algorithm, so it clusters our data. Now you can see here three clusters: one is blue, red, and green. Okay, so this was a clustering example. Now there are non-clustering examples also. For that, here you can see that's a video with an audio segment, with mixed narrator voices. Okay, first voice is of John and second is of Rory. Now, what our algorithm has to do is segment these two speeches, okay, from this audio file. Now, our no, our this unsupervised learning algorithm can do that. Now, we forgot to discuss about an example of clustering also, na? In clustering, the best example is of Amazon. Amazon has many categories, so it has to cluster those products into those specific categories, like example mobile, home appliances, laptops, PCs into the electronics category. So that can be an example of hierarchical clustering. Okay, now the next and the last one is the reinforcement learning, where we have an interesting theory which is called as no fringe free lunch theorem. No free lunch theorem. It doesn't exist actually, but it is taken as an example. This principle works on giving rewards to our agents. Like example, our agent is the mouse. If it does the right thing, so give it reward to our agent, so it does better next time.